Climate change is one of the biggest scientific challenges we face today. The reason it's so challenging is that climate change is very complex indeed. To understand climate change and to make useful predictions, we have to understand many aspects of our planet Earth. Climate change involves an interaction between the different components of the Earth system, the atmosphere, the ocean, the land, the ice, and indeed the biosphere, including vegetation and carbon coming from animals. And it's this complexity that makes it so challenging.
So this picture here in the background is one of the first, if not the first, Earth observation picture that was ever taken from space. And it was collected by a camera that was mounted on the top of a V2 rocket in the 1940s. And this is how Earth observation first started. People wanted to see the planet in a way that we can't from the ground. And you can see very clearly that it allows us to look at the weather patterns, and that's been a main driver of Earth observation over the past few decades, to look at the meteorology, because people are very interested in weather. But we now use the satellite technology to look at the climate system as well, because we know that Earth's climate is changing. This is a really famous image. It's showing the change in the mid-Pacific ocean temperatures as a consequence of changing patterns of climate. This is the El Niño or the La Niña event as a function of time. And the red areas are warm currents of water that travel across the Pacific Ocean and change the climate of the regions that are surrounding that part of the planet. This is one of the first things that was well understood from Earth observation in the early 1990s, I guess. Another famous thing that's been discovered, and this is an animation which shows some of the challenges but also the benefits of Earth observation data, was the ozone hole and how it disappeared in the southern hemisphere in the 1980s. And the satellites that we use to look at this part of the planet were originally not designed to look at the poles, and so there's a big gap in the polar region. But nevertheless, we can see that there is a diminishing ozone layer thickness, and that was an important discovery thanks to Earth observation data.
Well, the satellite era has definitely changed weather forecasting, climate as well, and chemical composition forecasting, because it was not possible from the ground to obtain a global view of the state of the atmosphere. Whereas satellites offer that possibility. You can have like a global view, instantaneous in some cases. For example, geostationary satellites, they look at one spot on Earth constantly, and they give a lot of high-resolution information on the state of the atmosphere. Also the so-called polar orbiting satellites that go around the Earth. A lot of things were not possible before the satellite era, just because it was impossible to observe such a large portion of the Earth atmosphere with the sensors based on the ground. They are extremely important, of course. They provide validation for the satellite data, but the satellite view is global, and that is what is really important about it.
Earth observation is fundamental to understanding climate change in the marine environment. It allows us to connect together our sporadic and sparse data points in a way that models don't do as well. Although the models give us a prediction, they're not using real data, whereas Earth observation gives us real temperature, salinity these days, ocean colour for things like phytoplankton and sediments in coastal zones, as well as the sea level height. And these are fundamental in trying to understand the long-term changes over the past decades and future decades that are occurring in our oceans.
Historically, we've only been able to monitor the oceans in specific locations when we've been able to send a ship out to look at that particular point. Earth observation has completely revolutionised our picture of how the ocean looks, because we've been able to get global coverage and coverage continuously over time. That's enabled us to build up a more complete picture both of the physics of the Earth system and also to give us a long-term data set to record changes to that system. The oceans are warming from the surface right down to the bottom of the sea, and we can see that signal. We also know that about 90% of the additional heat that's been stored in the Earth system as a consequence of the greenhouse effect has been stored in the ocean. And furthermore, we're seeing the significant change associated with an increase in acidification of the oceans, and that is occurring at a rate that's greater, we believe, than at any time in the last 300 million years. Changes in the polar regions affect global circulation of the ocean, and they also affect sea level rise everywhere through their influence on the ice sheets. One of the key datasets that I use in my own research is altimetry. That tells us the height of the sea surface, and from that we're able to deduce what the surface currents are. Having an indication of those surface currents helps us to understand the critical physical processes associated with the Earth's ocean circulation and also with the exchange of heat and carbon from the atmosphere into the ocean.